Let's demonstrate the difference between first and zero order processes using this spreadsheet. I've uploaded this spreadsheet to your course material so that you can use it to explore these concepts further. A first order process is when something changes, for example, the concentration of a drug in plasma changes, at a rate that is proportional to its amount in the system. In other words, the more drug there is in the body, the faster the rate at which it will decrease. As a result, when we plot the concentration of drug over time, we notice that the slope, which represents the rate at which the drug concentration is declining, starts off steep and becomes flatter and flatter over time as the amount of drug in the body decreases. This is why when we plot plasma drug concentrations over time for a drug of which the pharmacokinetics is best described as following first-order processes, we get a curve that suggests exponential decay. And when we transform the concentration values to a logarithmic scale, so a semi-logarithmic plot with the y-axis on a logarithmic scale, the curve straightens out. This is because a logarithmic scale represents proportions, and although the amount by which the drug concentration decreases over time is changing, the proportion relative to the amount of drug in the body remains constant. So we get a straight line, and we can see over here that over time, for every hour, the proportion of the drug relative to the amount that's in the body remains the same. Okay. On the other hand, the pharmacokinetics of some drugs follow what we call zero-order processes, and we will talk more about the reasons for this later in the course. In these cases, the amount by which a drug's concentration changes over time is constant, regardless of how much drug is in the body. So the amount eliminated over time is constant, regardless of the amount of drug in the body. As a result, we get a straight line when we plot the drug's concentration over time. But notice that when the amount of drug being eliminated remains because the amount of drug being eliminated remains constant over time, but the amount of drug in the body is decreasing, a greater and greater proportion of the drug is being eliminated over time. And this is why when we plot the time concentration curve for a drug with zero-order kinetics on a semi-logarithmic scale, we notice that the curve gets steeper and steeper over time.